Hi, and welcome to the videos for Math 126, Chapter 1, Section 1. This is the first of 4 videos. So in Section 1.1, we're going to be looking at real numbers. Their properties, things that we can do with them, ways we can manipulate them. So first we want to deal with some definitions. And that is to say, what are the different types of real numbers? And so this symbol here, it's going to be a shortcut for us. It's basically like a capital R, but it's got 2 bars on the left side. So that letter notation, that's a shortcut for saying real numbers. So we'll use that to save us a little bit of time instead of always having to write out real numbers. The first class is a natural number. And you can think of this as the counting numbers. So example would be what? 1, 2, 3, etc., etc., etc. So we don't include 0, and there's some argument, whole numbers, do we count 0, do we not, depending what book you're reading, 0 will be included, 0 won't be. But if we're talking about natural numbers, it's numbers we would use to count. If we're counting the number of students in a classroom, we wouldn't start at 0, we would start at what? 1, 2, 3, 4, etc. So that's a natural number. The second is an integer. And this is basically the natural numbers, their negatives, and 0. So we have 0, 1, 2, 3, etc. And also the negatives, negative 1, negative 2, negative 3, down to infinity. The third type of real number is what's known as a rational number. If you ever have trouble trying to remember what's rational, what's irrational, well, in the name rational, we have what? We have the word ratio. So a ratio is a fraction. That's what a rational number is. So it's basically a ratio of integers. So the formal definition would be that R, our rational number, is some number m over some number n, where m and n are integers, and we also have this issue that n cannot be 0, because 0 is an integer, but n can't be 0 because we get a 0 in the denominator, and that's real bad news. So ratio is just some number that we can write. So how about the number 2? Is 2 a rational number? Well, it is, because we could write 2 as what? 6 over 3. 6 over 3 is 2, so yes, 2 would be a rational number as well, because we could express it as a ratio of 2 integers. So examples would be what? 1/2, or negative 3/7. As I said, 2, because this is like 2 over 1, or 4 over 2, or 6 over 3, etc., etc. Could also have it as a decimal. So if I have 0.17, well, that's what? Tenths, hundredths. So this is the same as 17 over 100. So the decimal 0.17 is also a rational number because we can express it as a fraction. And then 4. So we have rational numbers, we have irrational numbers. So if a rational number is a number that can be expressed as a ratio of 2 integers, what do you think irrational means? Well, it means it's a number that cannot be expressed as a ratio of integers. So for example here, i.e. square root of 2. So if you were to put that on your calculator, it would come out and the numbers just keep running. There's never a repeating pattern to it. It's just the numbers keep changing as it goes. So there's no way that we could write that as a rational number. We would have a decimal, but we couldn't convert it to a fraction. Because we can't convert it to a fraction, a ratio of numbers, that's what we call an irrational number. Another one is pi. So pi is what? It's 3.1415926535, etc., etc., etc. It never ends, it never repeats. So we can't write pi as a fraction. So this is actually, this should say approximate, this squiggly equal sign meaning approximately. So as I was mentioning, there's nothing repeating here. None of the values keep repeating after a certain amount of time. So just as a note, when we have a repeating decimal, we place a bar over the repeating value. Sometimes it might be just one number, sometimes it could be multiple numbers. So for example, if I have the fraction 1/3, again, if you were to put this on your calculator, 1 divided by 3, you get what? 0.3333, keeps on going. The 3 keeps repeating. So what we can say is that 1/3 is equal to 0.3 with a bar over the top of the 3. And that's our indication that the 3 would just keep on going, but we don't want to have to keep writing 3's forever on our paper. So we can get the decimal value by doing what? We have a calculator or something, we can divide it, longhand division, 1 divided by 3, and it'll keep giving us 3's. But what if we want to go the other way? So what if I want to figure out, if I'm given 0.3 with the bar, how can I convert that back to a fraction? I know that 0.3333 is 1/3, but let's look at what the reversing of the process would be and how we would figure that out. So if I was told, or if I was asked, find a fraction, so let's call this an example. For 0.3 with the bar over it. So again, we know it should be 1/3. Let's see if it actually works out or how we would get that way. So there's basically a two-step process here. Step 1, I'm just going to take this value and set that equal to x. So I'm going to say x is equal to 0.3333 ... I'm going to write it out a few times and you'll see why, so I can keep track. Then what I'm going to do, and it depends on how many numbers are underneath of this bar, and we'll look at another example, actually in video 4 of this section will be just examples of doing this process, so you get comfortable with doing it. But I want to multiply this then by some number, 10. If I multiply a number by 10, what happens? The decimal moves 1 place. If I multiply it by 100, what happens? It moves 2 places. So depending on how many numbers are under this bar is essentially how many zeros I would have to multiply. So there's 1 number under the bar, so 1 0 is 10, 1 and 1 0. So instead now I'm going to say 10 times x is equal to what? Well, 10 times this guy, the decimal place moves 1 to the right, so it's really what? 3.333 and so forth. So if x is equal to 0.333, 10 times x I just move the decimal one place over and I get 3.3333. Now that I have these two guys set up, I can subtract one from the other. So 10x minus 1x, don't forget there's like an invisible 1 here. So 10 minus 1 is 9, so I have 9x. And x is basically the fraction that we're trying to find here. Now, if I multiply the right side, and this is why I wrote all these numbers out, and this is why you have to be careful what you multiply, because these guys all must be the same. They are in this case, and we'll see why they must be the same. But again, I'm subtracting the bottom from the top. So 3 minus 0 is 3. And what happens here? All these 3's cancel each other out. So I get what? Basically 3.0. And that's what should happen if you're doing this process, is everything after the decimal should become a 0. If it doesn't, you didn't multiply the right number in this first line. So now I have what? 9x is equal to 3. So divide both sides by 9. X is equal to 3 over 9. Divide the top and bottom by 3. I get what? 1/3, which we knew from earlier. But that's how, if we're given a repeating decimal, how can we find the fraction associated with what that decimal is? And that's how we would do it. And again, as I said, video 4 in this section is going to be just examples of problems like that. Because on your first exam, on your first midterm, on your final exam, this is a problem that's likely to show up, something like this. You're given a repeating decimal, how do you convert it to a fraction? So those were our different types of real numbers. We also have what are the different properties of real numbers. So the first property is that real numbers are commutative. Which is to say, order doesn't matter. For addition or multiplication. So if I have some number A plus some real number B, it's the same as B plus A. The order doesn't matter. Or if I have some number A times some number B, it's the same as B times A. Again, the order doesn't matter. 2 times 3 is the same as 3 times 2. It's commutative. The order doesn't matter for addition and multiplication only. Also for addition and multiplication, we have the associative property, which is grouping, so we can group it, and again is for addition and multiplication. So if I have A plus B and I add some number C, so right now I'm grouping A and B, but I don't have to necessarily group those two together if I'm talking about addition. I can also say this is the same as A plus, now I group B and C together. Get the same value for real numbers. And for multiplication, if I multiply A and B together and then I multiply it by a third number C, that's the same as if I multiply A after I multiply B and C together. So again, I can group them however I want. Doesn't affect my final answer. And then lastly, the third property of real numbers is the distributive property. And this is for multiplication only. And this says that if I have A times a group of the addition of two real numbers. So A times B plus C, I can multiply each of these values inside the parenthesis by A, add them together, and I'll get the same thing. So it's the same as if I do A times B plus, and this could be a minus as well, but whatever this sign is, so plus A times C. So again, if I have something of that form, I can distribute the number in front, multiply each one inside separately, then add them or subtract them if it's a negative sign, and I'll end up with the same value. So that's it for video 1, an introduction to real numbers, the different types that we have, different properties, and then again from an exam standpoint, how do we convert a decimal that's repeating into a fraction. So come on back and we'll look at video 2.